planned to address in the lab. So as you remember, this is an express DevOps section. So last time we gave a general overview of virtualization. Why are we studying these DevOps activities? Because particularly in the context of the cloud, there is the backbone topic of the lab together with data is that it is all about the way you deliver solutions is using virtualization techniques. So I consider that it was important to have a look at them. I am sure that while you have been doing your studies, you have touched these aspects. So here it's just having a look at the way cloud and virtualization can come together into these DevOps activities. Of course, I'm sure that you have understood that, I mean, DevOps itself and virtualization itself, you can have a whole course on these, getting acquainted to virtualization tools, learning how to prepare virtual machines in order to really go into a professional arena. Here, the idea was much more to give you these hints. If you didn't have the opportunity to have to touch these topics in a deep manner during your education, I vividly encourage you to, while you're looking for the next steps in your professional life, to have a look at them because they give you a lot of support and they consolidate your practice as computing systems engineers. So that's the message to have here. And so today we are moving into a second vision of virtualization, which is using containers, so another strategy in order to deliver solutions and eventually deploy them on the cloud. So the idea is to really connect both here. Just to tell you that, today we are going to have a quick experience, and eventually I have prepared other material. I don't know if we will have time to do it together in this session, but eventually that will be the last exercise that I will ask you to complete in order to have the last points of the lab before the final work. Now, the final work, just a comment on that. I will announce this for everyone so that you have in black and white the announcement. But as you probably have seen in the on Blackboard, there is already this last exercise that I'm going to use as wrapping up activity in the lab, is to have this Medium entry and YouTube or TikTok video. After the session, I will send again the specifications of what I would like to do, together with a spreadsheet where I would like you to write the idea of the topic that you want to address for both the medium and the video. In the specification of the activity, I gave some examples of videos that are today very popular, where people do flash mobs, they do many different, they dance, etc., in order to touch topics. There are songs, for example, for NoSQL solutions, criticizing more or less the practice on NoSQL, etc. So you can have a look at them, and then I will ask you during the week to fill in this spreadsheet with the ideas that you have, so that eventually we can discuss together, and you can focus exactly what you're going to write, because I believe that you know what Medium is. I'm right. No, you do know what Medium is. Okay. So, well, then in that way we can interact together in order to that you can prepare this and then the video. And I had officially said that this was for the second week of May. I saw that the exams calendar is there, and I know that the lab doesn't have any calendar, but I believe that we can consider that you can prepare this until the date of the regular course calendar, which is the 13th May, which corresponds more or less to the second week of May. So in such a way that you can have a good window of time in order to prepare, etc., and to hand in this last activity. Do you have questions until about this administrative issues? So if you don't, I'm going to start sharing the specification of the exercise that we will be doing today, but I will do an introduction. So again, motivation. There's a lot going on LinkedIn. If you are not on LinkedIn, it is time to go to LinkedIn, because now you are finishing your studies, and now you go to the professional market well, today, and particularly for us, we are in technology. It is very important to be active on LinkedIn. This is your show window, this is your showroom, and you have to learn to show your experience, your points of view, etc., on this um, social network. And then there are a lot of things going on that are often interesting. So I came across with this announcement from GitLab. There is a guide to getting started in DevOps. So the link is there. Of course, today the slides will be online. So maybe now you have many projects, etc. But again, as I said, after once the semester will be over, have a look at this. It's a very interesting thing. I went to the site. There are many activities and tutorials and so on and so forth. So it can be interesting to have a look at that. Okay, so as promised, this is something that we have already discussed in an intuitive manner, because when we did the Mongo sharding exercise, we used a Docker solution in order to externalize the execution of Mongo, and particularly on the construction of the cluster, etc. So in fact, me and Javier, now you know Javier, had prepared this sharding container, and we use this container in order to work on the MongoDB sharding exercise. So now we are moving back to this idea, but we will go further into some details, and we will have the experience of preparing a very simple component and using Azure in order to upload our container, etc. And as I said, have the experience of using the cloud in order to run our applications thanks to containers. And so, of course, the general um, concept behind containers is componentization. Okay, so that's the generic term, but then today we talk about containers, and particularly there are, as we have tools in order to build virtual machines, we have tools and systems in order to manage our containers. And a very popular one is Docker. So it's a computer software used for virtualization to have multiple operating systems running on the same host. So that's something that we have been discussing for virtualization. Of course, Docker is not the only the only solution. There are other solutions, but I'm using the most popular one. Okay. We will work in an externalized manner, but you have to know that it is possible to install a Docker engine on your computers and run the same activities that we are going to run on your local machines. It's just that, as I said before, since we are working in distance, I do not want to deal with installation problems in this setting, because we lose time, and you have more burden in order to install, disinstall, etc. So this is why I'm also using externalization. And since we are in the cloud, so this comes very in the right moment on the table. Okay, so now that we have discussed about virtualization, you have virtualization on the left side of the figure. And as we have been discussing, well, here you have a generalized setting of what I have presented in the regular course and in the lab. Of course, you have infrastructure. Now it's not a physical machine, but it's infrastructure. So you can have a specific physical machine, a rack of servers, or the cloud, and that is your infrastructure, and you want to have access to it under virtualization in order to prepare the right components that you are going to use in order to run your applications. And we have studied before that the key component in order to deal with this is the hypervisor. In this solution, now that you are quite acquainted with virtualization, this is the type 2 hypervisor, where in fact you have different guest operating systems, and the hypervisor directly interacts. Sorry, it's the number one. The hypervisor directly interacts with the infrastructure. And so you have your guest OS, and you remember here that there are traps in order to the operating system access the infrastructure through the hypervisor, and the hypervisor will act as a dispatcher of resources. So it will allocate resources and make sure that specific properties are respected, like isolation, like fault tolerance, and auto management that we have been discussing in the regular course. And as normal, you will have your code and libraries associated, well, living in the environment of the guest OS, and then the applications that will be running on top of it. And so logically, this is one computing environment, and this is another, and this is another, and we can have as many virtualized environments as we can divide the allocation of the resources of the infrastructure. Well, but people have seen this and they say, you know, this is kind of a burden because, well, first of all, you have at every time that we add a layer, being logical or physical in a computing system, we are adding overhead because there is communication implicated here. And when you have communication and when you have an additional program running on your solution, you open the possibility of having errors, of having other problems that you have to address, security problems that you have to address in this kind of setting. So people thought, well, how can we have lighter solutions in order to have access in a virtual manner to this infrastructure? And they came up with the idea of having engines that will have scripts, descriptions of specific environments that you would like to use. For example, an environment ready to use in order to build programs on top of mobile devices, or an environment ready to use in order to have access to ARM devices, together with specific hardware characteristics, and where the ARMs already have a DBMS installed in their kernel, for example. So people would specify these environments, and then the engine can instantiate the environment and run it on top of a specific an operating system that will be dealing with the actual infrastructure behind. Okay, so the idea is that you get rid of the hypervisor, which is already good, and that instead of modifying the operating system or whatever, you have the operating system that can interact with the infrastructure. And then here you will have the embedded environment that is necessary to run, for example, this application. Okay. In the embedded environment, you can still have an operating system as part of your environment, but this is grabbed together in this notion of container. And it's not living its life. It only lives its life when you run a container by the container engine. Okay, so nothing is happening until you instantiate and run it. And if there is nothing being done, then you shut down that virtual environment, and this means that you have less resources and less activities to perform. And in that way, you give a light version of the virtualization. And more interesting than that is that in the virtualization setting, if some component of your virtual machine, let's say that your virtual machine includes MySQL, and imagine that MySQL suddenly has a new version, or you have Java and you have a new version of Java. In this setting, you have to put down the virtual machine, update the elements, and then run it again. Whereas here, it's not necessary because the script remains logic. And so it will be only when you instantiate the container that all the dependencies will be retrieved, and so you do not need to deal explicitly with new versions, etc. It will get everything necessary with the right versions, etc., in order to build your environment ready to use. but that doesn't run all the time if the application or something is not running there. So you have many different advantages in order to dealing with this kind of solution. Now, to sum up, well, containers help to separate infrastructure and applications and deliver software quickly. Here, of course, you have certainly understood that the problem is time to market and engineer resources invested in order to prepare a solution. Okay? Person hours have a cost, and time to market has also a cost. So here the idea is that people can prepare very fast ready to use solutions, and that they manage them and they maintain them in a very easy manner. Okay. Now, unlike hypervisors, what we will be creating is here is associated to Docker, a level in which we are going to rely on the initial operating system, and we will have an engine that will run the virtual environment, which will be called a container. A container because it contains all the necessary elements that you need in order to run your solution. Now, the fact of not letting the virtual machine directly interact with the infrastructure is very interesting, because sometimes the underlying infrastructure can change too. Okay, so if you have this separation, you do not have to deal with new elements that could come on the infrastructure too. Now, Docker containers run in an isolated environment on the host OS. And the idea is that your container will be independent of the operating system running here. Okay, so you do not care about which operating system is managing your underlying infrastructure. You prepare your container, and then the Docker engine and all the Docker infrastructure will take care to deploy it on the target operating system. So that's also very interesting, because otherwise you have to enjoy yourselves preparing different versions of your solutions for different operating systems. And again, we are not scared about it, but this costs time. So that's the interest of this. So this is something that we had already seen before. You have the Docker architecture. So here behind, you must think about the existence of a Docker engine. Okay, and the Docker engine will have a client, the Docker client, and it has two important elements: the host and the Docker registry. Okay, so the Docker registry will handle images that describe what it is possible to retrieve as a running environment. And then the host will actually run the code of the image. Okay, so this is the script, and this is the actual computing environment running on a host machine. And of course, a container contains software. Okay, so it contains the operating system, it contains the DBMS, it contains data, it contains anything you need in order to run your system application or etc. Okay. And so the question is, well, how can we access a registry? So for the time being, as we have this intuitive use of registry, we used, for MongoDB, we used a Docker Hub, if you remember well, where the Docker Hub had a container with the right MongoDB that we were using um, for our solution. Well, Docker registries, there are many. The Docker Hub is a public one provided by Docker. Today, or not today, but in the exercises that we will be doing in the lab, we will use Azure Docker registry in order to deploy an image of our own in such a registry. And then, well, as I said, the host can have different containers running that are copies of these images. And then there is the Docker daemon. The Docker daemon is the one that helps interact with the operating system, in fact, of the host, and lets deal with these different containers running on the host. And then you have, of course, the Docker client, and the Docker client that, again, you remember certainly because, for example, when we use play with Docker, we use these commands in order to pull something from Docker to run a container, etc., which is interacting, in fact, with the daemon in order to manage the containers that we want to work with. So to sum up, the Docker engine is the client-server type application, which means which has the clients that rely on the server. Well, that's normal. Then you have the Docker daemon. This is a vocabulary from Docker. Okay, so I'm just introducing it because we are using Docker. It's not the general vocabulary of componentization. In the vocabulary of Docker, the Docker daemon is called the Docker, and it represents the server. And then they can run, the clients and the Docker can run on the same or in remote hosts, and they can communicate either through the command line client binary or through RESTful APIs. Okay, so if you remember from your distributed systems course, you remember that there are two types of addressing services. One is using the W3C specifications, for example, with SOAP, with interfaces defined in WSDL, or you can have the one that is today most commonly used, which is the RESTful API, where in fact RESTful is an architecture where in fact you use the URLs with the operations, the right operations in order to address the service. Sorry. And so Docker can be seen as a service, which is good news because if you think about the cloud, in the cloud, the unit of construction is service, and normally we interact with cloud services through RESTful APIs. So this is very nice because Docker can lie in a cloud, and we can use it as a service from the cloud in order to have our solutions. Docker images, you have to understand Docker images as a source code, okay? So the image is the source code of the containers, for containers. So we use them to build containers. They can have software pre-installed, which speeds the deployment, speeds up. And they are portable, and we can use existing images or build our own. So in the lab that we used images, we used an existing one. And in this last part of the lab, we will have the experience to build a very simple image so that you can have the full experience on doing this. And then the registry stores images, and then it can be, well, registries can be public or private, as we said, and as I said before, we have used the Docker Hub one for MongoDB. And Docker Hub, well, if later on you want to play with Docker, Docker Hub has millions of images of everything. So when you want to build an image, first have a look on Docker Hub and see whether it doesn't exist there, because otherwise, I mean, you do not need to invest time preparing an image. So us as computer systems engineers, and particularly if we have the DevOps hat, our role would be to prepare images. Okay, a lot of images, la 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 la, and then others will use our images in order to run them and have our solutions ready to use. And finally, Docker containers, they are organizational units. So this is the container is the basic component of a Docker solution. It runs an image. So in the Docker vocabulary, they associate the container with the analogy of a container, a real container that goes in boats. Because it contains software and other running components in order to run a solution. And what it's more than that, and that completes the metaphor of component, is that you can modify, you can manage, you can create, you can get rid of them, destroy them without, I mean, in a very simple manner. So this administration of the whole package of solutions that can be very complex is very easy to manage. So if you are a DevOps, you are interested in that because you have to deal with many different containers, and so it's important that you can manage them in a very easy manner. And again, this is just the black and white description of what I have said. An image is a template and a container is a copy of the template. And the interesting thing is that you can have many copies of your of this template. So for example, in the case of the labs in the university, how many computers are there in a lab? I don't know, 20, 30, 40. It's been a long time since I haven't been at the university in Mexico, but well, you can have, I don't know, 30 computers. Of course, you are not imagining that the TI engineers will go machine by machine installing things that we can use in the lab. In fact, what they do is they have images and then they deploy in batch the containers on top of the computers so that they cannot go machine by machine, and they make sure that everything runs without having interdependency problems or whatever. And then once the semester is over, they delete the containers and the machine is clean, and so the administration of the machines is easier. Okay, so with this, let's move to the first part of the hands-on, if you do not have questions before. Please, Mauricio.
Yes, hello, dear. It's just that I'm a little bit confused. The no, Docker, sorry, Docker register. Where,
Registry?
yes, where we have this Docker registry.
The word. in
And
Docker servers, in Azure, Microsoft Azure, in a cloud, in AWS
ah,
cloud, somewhere.
okay, okay.
And so we have to use an existing registry in order to store our images. Or you can have, of course, one in your organization. That's possible too. But you still have to have a registry, so a box with your images.
Okay, and the host is our computer, right? Or the system
Yes,
we want to.
yes. The host is the computer with Docker installed.
Oh, okay.
Okay, so the Docker is the engine. Okay, so you install Docker on your computer. Now, well, you run it, and now Docker engine is running. And then it has a client. It's a client server component. And so you use the client in order to tell Docker, your Docker engine, contact this Docker registry and pull this image. So it pulls the image, and then you say, now run it. And so it runs it on your computer with no installation required,
Ah, okay. Yeah, I think it's true.
right?
Yes.
Mhm. You're welcome. More
And
questions?
yes, can I ask another
Yes.
question? Sorry.
All the
Eh,
questions you need.
for example, it's just that I didn't get what is Docker daemon. So like it manages the containers.
Ah, now you have, so you install, as we said, we install Docker engine. Inside the engine, you have Docker daemon. And Docker daemon knows how many containers are running now, time t, on your machine. And then it can create them, it can stop them, it can, all the management that you need.
Ah, okay. Yeah. Okay. Okay.
Mhm. Because, I mean, you have to think container, in fact, is as if you had a little machine running inside your machine. And so you have many machines running in your machine. Now the daemon has to know how many of them are there. And it interacts with your operating system because at some point there is a limit, no? Because your machine has limits. And so it manages these issues.
Okay. And for example, the who is the in charge of asking for allocation of memory?
The daemon,
The
the
daemon.
daemon
Ah, okay.
together with the, yes. So you have um, before here. You see, here it's the operating system. So let's think that we have only this little machine, okay? So the daemon inside the engine interacts with the host operating system in order to do the necessary to ask for resources and run the containers. So the containers never interact directly with the operating system. It is the engine that does.
Okay.
And in that way, you also avoid having malicious containers
Oh yeah.
because there is the screen of the container engine um, making sure that you do not do things that you are not allowed to do.
Okay, perfect. Thank you, teacher.
You're welcome. More questions? Okay, so if there are no more questions, so let's go to the hands-on. So I'm not sure if someone got connected later, so I'm going to share again the link, okay? So what we are going to do is a very simple exercise. It comes from Microsoft Azure tutorials. And the idea is that we're going to deploy a container instance in Azure, and we're going to use Azure CLI, okay? A lot of terminal, right? So for the time being, so the first part will be we use a container instance in order to run an application. And then later on in the second part of the exercises, then we will create an instance, okay? But for the time being, we're just using an instance and running a container on Azure. So of course you need your Azure account. So the objective is to have a first experience in deploying an existing Docker container on Azure using the CLI service. And remember that now we are using a service, so we are using a terminal service. The idea is that we are going to deploy an isolated Docker container and make its application available. So inside the container, we will have an application, a dummy application, okay? A dummy application within this container, and we are going to put it available in fully qualified domain name, okay? So visible to the world. Yes, to show you that, of course, containers plus cloud, you are in turbo, okay? You are being able to execute and prepare things in a very easy and efficient manner. Okay, so first of all, you have to click here and you go to the cloud shell. So as on TV, then I'm already here. Well, I'm going to shut down here. I'm going to shut down many things that I have because I will be I'm going to get confused with you and I'm going to confuse you. Right. Okay, so when you click, you will land in the Azure CLI. Okay, so if in previous labs, what we have done is we installed Azure CLI, for example, in Colab in order to be able to run things. Now today, we are doing the opposite. We are relying on the CLI service on the Azure portal, and we will be using it in order to do this first part of the exercise. We have the yes. So what do we have to do? You have guessed. Now you learned from the previous lab. The first thing that we have to do is create a resource group. Okay, so we are going to do this to create our resource group. And yes, of course. I will share, in fact, the I'm I'm going to Slack and I'm going to share the Word with the exercise, because of course I'm like a student. I uploaded the specification at the last moment, and I might have errors there. So I'm uploading the Word, and please copy from the Word file and not from the um, from the online thing, because it might have problems. So this is something that we did last time. We used the terminal in order to create our resource group. And remember that if you go to your portal control, there you can see that your resource group is already run. Okay, so that's first thing. Then once we have our resource group, we are going to create a container. Okay, so we are going to create a container that already exists. Okay, so we are going to use an existing container from Azure Docs. So if you, yes, you're having a look at this. So we are in Azure. We want to create a container on top of the resource group that we have created now. We are going to name it my container. You can of course name it as you prefer. And we are saying that the image is lying in this address. So this address is the Azure Docker registry. Okay, so the image is called ACI Hello World, and then you have to give it a name, a DNS name. I'm going to use the name of the lab in order to name to give it a name on the DNS, but you can name your application as you wish, and then it will be listening in this port. If at some point you get lost, you cry out. So it takes a while depending on your connection. Okay, so what do we have here? A huge JSON. It says the description of the container. So the container comes from the image called ACI Hello World. Nothing is happening now besides the fact that now the container, well, the image is running. Of course, you have a lot of timestamps that represent the status of the execution of your container. What else it is important? We are not using encryption. We have specific ways of having access to it. So we didn't do anything with regards to security for the time being. we have the DNS name label that we labeled, we specified. So in my case, it's LIS-4112. And this means that my application will be accessible in this address on the IP disk, listening on port 80. Yes, please, Alexander.
Excuse me, doctor. I just wanted to say that when I try to execute the previous command, it says that the DNS label LIS-4112 is already taken. So,
Yes, it already exists because I use it.
okay, so we can put any other one, right? Like
Yes,
our
you
ID
have
and
to put
then,
your own, for example, LIS 4112 Alexander or
okay,
Diaz
like
or
our ID or
anything,
something.
or Alexander Diaz. Right. It's good that
Okay,
it happened because I didn't clarify this.
all right then. Thank you, doctor, for confirming.
You're welcome. So remember that DNS has unique names. Okay, so that was the first thing. So it takes a little bit of seconds, and we can check the status. Well, in the Word you have the what I obtained when I tested it, but we can go and test it here. So at every moment you can use container show on your research group. Um, the name of the container is my container, and you are asking to give the status of a fully accessible process. I mean the container on the status of it, no? And so you have that this container with the application inside is running successfully. Now, since it's running successfully, so we can go and see it running. Now, so if you copy your address, in the browser, you will see your dummy application. So just to make sure that you understand, we got the image of an application, or the image that specifies that an application should be run. I mean, a web application is inside. Then we retrieve this image. When we run the container, we label the application with a DNS name in such a way that we can access the application running on Azure on our browser, I mean in the publicly, you know? And as I said, with no control of, no security control of it. So we didn't, for example, in one of the exercises that we did on Collab, we use ngrok, for example, in order to make sure that we have security protection on top of our application. Here we are going to the world without any control, okay? Because, well, here we are just testing containers. Now, if you want, well, now you are the administrator of the application, okay? So you want to have a look at the logs of the application running in order to make sure, I mean, to have a look at how is it running. So if you want to do this, the container generates a set of logs in order to follow the execution of what is being run inside that container. So if you refer, for example, to the regular course, at some point in the last time, I described a virtual machine with many different, as a set of files, where one of the files were the logs of the virtual machine running status. So here is a similar thing. You have the container running, and so you want to have a look at the running status of your container. But your container, in fact, is running things inside. Okay, so what you want to know is how are the logs about the running status of the elements that are wrapped in the container. Yes, please.
Yes, sure. It's just that my provision state is succeed, but when I go to my link, it
You have to wait a little bit.
okay.
It
I was
takes
worried.
time. Yes. So
Okay,
wait a little bit and then you try again. Mhm.
okay. Thank you, teacher.
You're welcome. Let me know when it works. Well, it seems very simple, but I mean, we are going to some data center in Azure. We have installed our container in the resources that we prepared in our resources group. And now uh, I mean, it starts running, it generates the DNS. You know that the DNS has to be updated, no? So we create the label, the DNS is updated, and at some point it is visible from the web. This is why it takes time. And so if you run and run, if you refresh and refresh, no, this no. The application one, this one. And you refresh and refresh, then eventually you can see that the log changes. You see, it has been executed from Safari, well, in my case, at many different instances, you know, at 1555, then at 16, then a second later, and it's running from a Macintosh Intel, so this is me. And this is the version of Safari. Yeah. Well, this is the version, the Safari thing that I'm using. So if you click, then you have the logs generated there. Now, I hope that this will work because yesterday I had problems with this. So besides viewing the logs, you can attach local standard out and standard error streams from the container. So this is to have a look at the status. I didn't even copy the link because at some point I was having problems. Then I will have a look at it and then provide the right operation so that you do not struggle with this. But the idea is that instead of having a look on CLI about the logs, you can get the logs, for example, on top of your machine, and then you can, from distance, have a look at the logs and understand what's going on with your application. So instead of seeing them here online. That's the idea of that last part. And then we are going to do as in previous occasions. We are going to clean up resources, and we will now move on to a more interesting thing to do. So, what do you have to bear in mind from this quick start exercise? Is you have to make sure that you understand where is the registry, where is your Docker engine, what is what is the content of the container, and what are we doing when we run the container, we name the application, and we make it visible by the world by giving it a logic name used in the DNS. Okay, so that's the sequence of elements that you have to be sure that you picture in your mind. So while you picture them in your mind, I'm going to start cleaning up. So I'm going to clean up my research group. That's something that we did last time too. And then we are going to make sure that we really did. And we did because there are no, at least in my case, there are no resources groups running for the time being on my Azure environment. And so we deleted the container. Sorry, this is the container. So we deleted the container, and now we are going to delete the. So I went faster than the music. What I did first is I deleted the container from my resource group, and now here there are no containers running in my resource group. And now I'm going to delete the resource group. Now it takes a little bit longer. And while it is finishing, I'm going now to, and of course, if you do not have questions, this is the moment for questions before we move on to the next exercise. Now, this is a little bit laborious. We're going to go beyond things. Yes.
Yes, doctor. When you mentioned at the beginning of the exercise a Docker container by Azure, is a Docker container the same as an image? What's the difference?
I'm going to share this, right?
It's like the source. Okay, okay.
You see, in our case, well, in the case of the exercise, Docker registry is the Microsoft Docker registry, which well, I'm going to show you the line in the document. So, as I said in previous ways, we have the Docker Hub with which is an existing registry. Now we are using the one provided by Azure, and it lies on Azure Cloud, right? Now, there would be two possibilities. The one that we used today is we have a host on the cloud too. Which means that when we created the resource group, in fact, we created a running environment, right? And within this running environment, we well, it has the Docker engine. In fact, we are not installing it because it already has it installed. We will see in a moment that if it doesn't exist, we have to install it anyway. So we have this environment in the resource group, and then we use CLI as terminal to access our this computer. Okay, and then inside, when we uploaded, if you want, the image into this host, and it became our container.
Oh, okay.
And inside the container, you have the node application that will run.
Yes. Oh, and I think I understand now.
Good.
So we could see Docker images like an abstraction and like an actual container as the implementation of
Yeah,
that.
but it doesn't, yes, it's just a script. So
Oh yeah.
as we said, the virtual machine is a set of files. This is also a file, blah, 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 with many specifications of what it should contain. And in fact, when you pull it, it materializes all the things that are said that should be there.
Oh, okay, I see. Like dependencies, right?
Right? Yes. So if it needs MySQL, it goes and retrieves it, and file system, and a set of data, and everything. So it reconstructs. It's like the specification. You have to reconstruct this and this and this and it, and so when you upload it, the engine will go and get everything necessary in order that your container corresponds to the specification of the image.
Oh, I see. Okay.
Mhm.
Thank you, doctor.
You're welcome. More questions? And now, thank you, because now it has finished. So um, we have cleaned, and we are going now to use other things. Okay. So in the new exercise, we're going to go further. We are going to create a container image. We are going to deploy it on a registry, and then we are going to run it. Okay, so now we are on the side of the registry. Azure Container Instances enables the, and of course, so we are having a look at the Azure solution, okay, because we are in the cloud computing course. If we weren't in the cloud computing course, we could do reproduce the same exercise, but without going through the cloud, okay? So this is important that you know, because you do not have to use absolutely Azure or any cloud in order to use this. You can independently create your images and run them. I mean, if you are curious, a thing to do would be that you install Docker in your machine and you run what we're going to do locally, okay, so that you can see how does it look like running on top of your machines. Well, now the important thing to see in this setting of exercise is that since we are using Azure, with Docker, we do not have to create a virtual machine, which is the very first thing that you have to see with respect to what we did last Tuesday. is exactly that. In last Tuesday lab, Javier showed you that you create your resource group, then you specify the kind of a computer that you want to define. You create this computer in a virtual manner, and then you can create several computers with the similar characteristics or different characteristics that will be associated to your resource group, right? Here, the setting is completely different. We do not have to create virtual machines. We are going to use the running environment provided by Azure in order to run all our things, thanks to the fact that what we are going to deploy is our containers that inside will be running environments that will let us execute what is inside the container. Okay, so that's simple, very little details that you have to be sure that you see so that you can understand the difference. Again, this it comes from the Azure tutorials, and what it contains, the image that we are going to do is the same as the one we've seen. So, but now we are going to see that there is a Node.js web application contained in the image that we are going to define. Okay, so if this application didn't exist, what we would do as computing systems engineers is we implement our web application as we are used to do. Okay, happy we have this application, and now we are going to put it inside the image, okay, in order to deliver it to our users, our consumers. Okay, so that's what we're going to do. But since we do not have a lot of time, we are going to use an existing application provided by Azure or by Microsoft. Okay, and so this application is on GitHub, available on GitHub. So we are going to clone the application. We are going to create a container image that will contain this application, and then we will test the image. Okay, and then that's the first part of the exercise, and then if we have time we will do it together. If we do not have time, then you will complete the second and third part of the exercise. Once we will have this image, then we will upload it in a registry. Since we are Azure users, we are going to upload it on the Azure Container Registry. This is the second part of the exercise. And then we are going to deploy container instances of this image in order to test them. Okay, and that would be the third part. And in that way, you have the whole life cycle besides programming the application. So you program your web application, you grab it in an image, you put the image in a registry, and then you pull the image into a container. You can run several containers running your application. Okay, so that's the big picture of the exercise. Okay, and remember that the word is on Slack. Now here things are not that easy. As I said, in order to provide a simple solution, I decided to use Play with Docker in order to avoid installation problems in your different machines. As I said, one interesting thing to do would be that eventually you really install Docker on your machines and test these on your machines, okay? But for this TV exercise, we're going to use again Play with Docker. So you need to recall access to Play with Docker account. Now, so well, we will use Azure CLI. Well, again, if you are in your own machines, you would need to install Docker. You would need to install Azure CLI on your machine, and then, well, understand Docker, but I have had a generic explanation of Docker, and then, as I said, make sure that you have Docker installed in your machine. So there's Docker for macOS, for Windows, Linux, etc. Right? So now, well, we are going to play with Docker. So I have to go to play with Docker. Start an environment, and you have an instance of a machine. So that's my first line. And now, since we are going to need Docker, we are going to install Docker on this machine. Please.
Excuse me, doctor. I think I missed. Where can we find this file to follow it?
On Slack, in the general channel.
Ah, okay. Thank you, doctor.
You're welcome. Thanks for asking. So I wait 2 seconds so that you can open there. So this is something that you would do in your local machines, no? So you are going to well, here first of all I'm installing Azure CLI, and then yes, right. I would have to install Docker if I wasn't playing with Docker, okay? But here I'm not installing Docker because since I'm playing with Docker, Docker is already here, okay? So if you go to your own machine, you have to install Docker, install Azure CLI, okay? So these are the two things that you would have to do if you work eventually on your own machine. Here in my setting, I'm just installing Azure CLI because Docker is already installed in the instance provided by Play with Docker. So you enter to the questions. When
Doctor,
it asks, yes, sorry.
sorry for interrupting, but where is the curl command that you just entered in the console?
Well, I'm going to the top and then I show you. So you have the objective, the
Yes.
intent, material prerequisites to do, and here is the curl.
Oh, okay. Thank you.
Right? And you execute it separately. No, first you curl, you install Azure CLI, and then you execute bash. It takes a little while. Please, Mauricio.
Teacher, I think we have a different version of the
Ah,
document,
yes, I think we do.
A different version of what?
that you sent in Slack.
Maybe I uploaded the same document twice. Wait a minute.
Yes, it's just that it doesn't have the curl to install the Azure SLI.
Have a try on this. Otherwise, I'm going to write it on the one I'm using. I'm going to put it on the chat. It's on the chat. So the name is container 123.
Yes, for some reason it still doesn't appear, but I'm going to use the one that is in the
Okay.
chat.
Thank you for telling me, because what I will do is, well, it's already online, but as I said, I did it at the last minute. So I have to make sure that everything that is online corresponds to the right, the problem is the format, and so that it will be formatted so that um, you can complete the exercise, right? But it's good that you tell me that for some reason it should transform it, or I don't know why, because I'm just uploading the same file that I'm using, and for some reason it doesn't. I'm going to copy the lines on the chat so that you can, and then you execute bash when it finishes. But it takes a while.
Excuse me, doctor.
Yes.
After running the curl command, it tells us to give a name to the directory in which we want to install it. Should we
Yeah,
give it a name?
you say enter, and accept what it is proposing.
Okay, thank you very much.
You're welcome. Problem is that, yes, almost there. You have your CPU consumption here, memory consumption. Well, the bad thing with this is that you have to do the whole exercise on a shot during 3 hours, otherwise you lose your, or you have the courage to install your environment on your own machine and then get rid of this. Of course, if you decide to install it and that you have problems, do not hesitate to contact me on Slack. Mm -hmm. So while it is finishing, what will happen, as stated at the beginning of the exercise. So what we will do is, as I said, we are using the same application that we used in the previous one. So it serves a static HTML page, but that you have already seen. And so we're going to clone it from GitHub. And then we are going to create an image, a container image. So the script looks like this. Of course, in this exercise, everything is facilitated, and we and it already provides the right Docker file. But if you want to create your own image, what happens is that you have to create a Docker file, and the Docker file looks like this. For example, here we are using Node 8.9.3 in Alpine. We are going to create a directory where we are going to put our code. We are going to copy the application to the directory that we have created, and this will be the work director. Then we will install npm, and then we have the node, well, the index of the JavaScript of our application here. That will be run by nodes. You see, so that's the specification of the image. So let me have a look at my status. Yes. Bravo, it has finished. So now I am happy because I have CLI running. Then I execute bash. And the first thing I'm going to do is have a look at what I've said. So in the no, I'm first going to clone the application. Otherwise, I cannot have a look at anything. So I'm cloning application, which is very small, so there's nothing to do. And then yes, you see here, well, I cloned my application, and here I have my application. And just to have a look at the Docker file that has already been provided. I'm going to cut it. So here you have it. So we cloned the ACI Hello World application. Inside, they have already provided us with the Docker file, which I have explained previously. So it's everything necessary, so the code of the application, of course, and everything necessary to be done in order to install it correctly and then run it with Node. And then you have to go back to the and now, well, we have the code of the application, we have the Docker file provided by the example. As I said, if we were doing the whole solution from our own, we would have to write on our own the Docker file, and then what we are going to do is create a container image. And the container image needs to be named, okay? And well, in the jargon of containers, this is called tagging your image. And so, well, in this exercise, we are tagging it as ACI tutorial app. Of course, you can change the name as you wish. Just make sure that I just know back. Just make sure that eventually you keep using the right tag application. And so what you will build is your, at some point, the image. And once it will finish, you can ask it to list the images you have. So I only have this one, which is the ACI. So here I'm requesting, I'm querying the Docker repository, and it contains this image. Well, it contains another one, but it's a very old one. Let me see, 4 years ago. So there's litter inside. And then this we will not do together, but the idea is that you will wait. I will send a message to make sure that I will have shared the right document with all the formats correct, so that you can complete the exercise, which means now for the time being we have created the image, then we have to test it, and in order to test it, we're going to run run it. I mean, create a container and test the container, and then run the application. Okay, that's one thing. And the other thing, but for the time being, the image is there, but it's not yet in a repository, which shows the kind of production cycle that you would have. Again, you implement your application, you grab it on an image, and for that you specify your Docker file. Once you have your Docker file, you create your image, and then you test your image, which is the last part that we are not going to do together. So to make sure that your image runs perfectly, etc. So you create a container locally, and you test that everything is running correctly. Once you do that and that you are sure that your image works correctly, then you push it on the registry. And then it is ready to be used by anyone that can have access to that registry. And this would be the next part of the exercise. So pushing your image into the registry, and again, well, this will happen in Azure. Then you will test again that your image exists now in the Azure registry, and then you will test it. Okay, so you will push it, as on TV, you will make sure that everything is fine. And then the third part will be deploying. Now you are going to, once you will have pushed the image in the Azure registry, now you are going to test it on top of Azure. So you are going to deploy a container on Azure, and you are going to test the application. Okay, and in that way, you will have done all the cycle locally first, well, we play with Docker, in order to make sure that this works, and then you push it on the cloud and you test it on the cloud so that well, that it can be seen by everyone, and then eventually, then you can imagine that eventually you would provide security and other aspects in order that your application is running for the world in the best conditions possible. But this you will do on your own. And with that, that will correspond to the last exercise that we will do for the last part of the lab. For grading, of course, okay? We still have one lab to go and we will do many things in that lab, but I mean, the things that you have to hand in. Questions until here?
None for now, doctor.
Okay. And again, start thinking about the final medium, etc. As I said, by the end of my day, I will send the announcement, the right version of the specification of the exercise, etc., so that you have everything necessary to wrap up the lab. Thank you, Jose Antonio. Yes, that's the one for the lab. And we have the regular. So in fact, just to give you the big picture of what the lab will finalize with DevOps, as we had stated from the beginning. And then regarding the regular course, we will give theory about componentization. And we will discuss still the data divide with ready-to-use machine learning studios that are virtualization, etc., componentization solutions, so that you can see a professional one, and that will be it. So we are really getting close to the last topics with this general overview of the huge world of cloud computing and big data, etc. It has been a huge overview just to point you into the cool things that can be done. Some of the cool things that can be done regarding the cloud and data. Okay, so I'm going to stop here. And I wish you a nice day. The last activity, the very last, well, the medium one is for the 13th of May, the medium one. And this one will be, I don't know, for the next week, by the end of the week, so that you can really forget about the lab and do what you need. Yeah, after this one, besides the final work, there won't be more homework. We will do things, but not for homework. Thank you. Thank you all. Have a nice day. Yes, nice day. Bye-bye.
Thank you, doctor. You too.
Bye.